Hi everyone, let me welcome you to the fifth session on EST 102 C programming. In this video we see the operation with arrays in C. So the speech is organized into your learning outcomes: array operation C in C, declaration of array, then multi-dimensional arrays, then character arrays, then the standard library functions for strings, then the summary of understanding. So your learning outcomes are: you will learn to declare and use an array in C, then you will learn to declare multi-dimensional arrays, then you will realize strings as character arrays, then you will learn the standard library string functions from string.h. There's a standard library function called string.h located in /user/include in a Linux machine, just like stdio.h. Often we have to do a lot of computations with large sets of identical values, especially in scientific computing, signal processing, etc. This C programming will be very useful when you do your lab in digital signal processing, probably in your 7th semester, where you will work with real-time signal processing with DSP chips or dedicated DSP hardware. So there you will encounter large arrays of identical elements, like when I say identical, like all may be integers, all values may be float, things like that. An array is a data type used for this purpose. C arrays are collection of identical elements. See, all elements will be int or float. So you cannot have an array with one element as a character and another element as an integer, or a third one as a float. No, they should be homogeneous. Everything should be of identical data type. Every element should be of identical data type. There are no default strings in C. Strings in C are but character arrays. Now, if you want to declare an integer array, it is something like this: /include stdio.h. That is, I include this stdio.h from /user/include. That is a standard IO header. And I open a main function, void main, and within braces I put this code block as an intended one, like int vals 5 within braces 10, 40, 70, 90, 120 entered by a semicolon. So this is how I declare an array. The all elements in this array are integers, and there are 5 values in it. There is the size of the array, or the number of elements in the array, and number of these elements are 10, 40, 70, 90, etc. You can take these values, like I can say printf %d, because these are integers, %d, val 0 will type the first value, that is 10. If you say vals in square bracket 1, the 40, number 40 will be printed. Then you can say printf %ld, \n size of vals. The size of actually returns not the number of elements in this vals, the array vals, but the number of the number of bytes or memory locations served for this array called vals. Okay, we will demonstrate this. I will go to my talks here. Okay, here I have a code here. Probably this is the one. Yeah, this is the one. So we will run this code with a GCC compiler. Now we can see that the first value is a 10. Here I have put as floats. Okay, the type is put as float rather than integers. So that first value is printed as 10.00, because I will zoom this a little. Okay, this 20 is 20 bytes are reserved for this. 20 bytes are reserved for keeping the storing the array vals. Now what if I make it into an int? You can see the change. Yeah, I should change it as %d. I'm sorry about that, because now it is a no, not a float value but an int value. Now I go back here, then I press /a.out. Okay, here you can see that number is a thing. 20 bytes are reserved for that. Okay, so the size of what it returns is the number of bytes required for storing this array vals, and not the number of elements in that. So vals looks like in memory after the definition as below. That is, this is val 0, 1, the third location I vals 2, vals 4, etc. So this is how this the array resides in the memory location. Now size of returns the number of bytes you reserve for the array, not the number of elements in the array. Now one can initialize an array without specifying any dimension, like a float a blank 2.55 4.34. That way also you can specify an array without specifying the number of elements in them. Now you can have multi-dimensional arrays. Suppose you work with matrices or large images or something. You may have 2-dimensional data, or you may have 3-dimensional data. Okay. Suppose you are working with a satellite signal. Sometimes you work with a hyperspectral images, like maybe 20 channel typically. So you may have large multi-dimensional arrays in data analysis. So I can do that with float x34. Okay, this is a 2-dimensional array. This is a 2-dimensional array. Okay, and multi-dimensional array is possible. Like if you want it in 3 dimensions, you can have float y2, 243. That's a 3-dimensional array that holds 24 values. This holds 12 values. There is no string variable. Default there is no string variable in C, but character arrays are possible. Like a car, this is the data type is a car character A20. This is 20 elements are expected in this, equal to within quotes you say ANSI ended by a semicolon. Okay, then there are standard library function for string. Okay, there are some standard library functions for string. They are included in the string.h file, or string.h header file. So in addition to stdio.h, I have to include string.h also. So here in this code, after including string.h, I open a main code as that returns nothing, void. And within braces I write car A20 and C, car B20 as A and J, A, L, I, like separated that way. Then printf function. So length of this is strlen. So what is the use of this strlen? That is to calculate the length of the string. Okay, unlike the size of command in array, what this strlen returns is the length of the string. Okay. So we will run this code and appreciate that how the strlen works. So this is my code. We will run this. That is str1. We will clear this here. -o a dot out. Then /a.out. So you can see that length of the string B, A is ANSI, and other one next is okay. Now this has a length of 5, and this has a length of 6. Okay. Okay, length of this string A, that is strlen A returns me 5, and this strlen B returns me 6. So you can see that here. Okay, A equal to 5, that is string A has a length of 5 and string B has a length of 6. So that is the purpose of strlen. That is how it computes the length of the string. strlen. This comes from string.h. Then strcpy, that is to copy the contents of one string to another. Okay, strcpy, that is to copy the contents of one string to the other. So in this code you can see that character A20, that is this character array is ANSI. Then I have declare a character array B20 and C20. Then strcpy B comma A means whatever is in A, that is copied to B. Okay, then I can copy to string C the word the string friends. So then puts B and C will print the strings B and C there. So here I use strcpy puts command. Now this I can take from another code. We will appreciate that code. Yeah, here it is. First a character array is written as ANSI. Then I have two character arrays. I haven't I haven't added anything to that. But when I use strcpy, here A is copied onto B and the string friends is copied onto C. When I use this puts B and C, that will put ANSI and friends. Whatever the content of B and C, that will be printed in the terminal. So that is str2. Will not run. It is gcc str2 .c minus o a dot out. I say a dot out. So this is strcpy. Now what is the content of B? A is copied onto B. A was originally ANSI, that is copied here, and C a string friends that was copied onto C. So that is what it is typing here using puts B and puts C. Now that is strcpy. So we have seen strlen, then strcpy. Then for concatenating or combining two strings, I can use strcat. Okay, strcat or strcat. So like I have one character array here, ANSI is my best friend, she, and this array, this string has stopped there. Then I have character B of size 100 is staying at column. Now when I say strcat A and B, the array, the character arrays will be combined. That is strcat, the concatenating strings. strcat is used for concatenating strings. So that is str3. So this is my thing, and this is my first character array A, that is ANSI is my best friend she, and character array B is staying at column, and character array C and is in quarantine So if I use a first strcat, B will be appended to A, and when I use this strcat AC, this last part, the last string also will be appended to this. Now you can see that this is a first concatenation. ANSI is my best friend, she. Then is staying at column, that was the second string, that now it is concatenated with the first string. Now this being there, this is my new string A. Now and in quarantine was a third string I attached with the first string A. So this is how I concatenate string with the strcat. Then comparing strings, you can use strcmp, that is for comparing two strings. So like I have a character string ABCD, then another character string AB capital CD, then I have a character string ABCD. So result I say in int result result2. Then when I say result strcmp a comma b, So it will it will compare the two strings and give the result. That is strcmp. That will be str4. Yeah, here you have. Oh, of course, I use a different string here. I will put it ABCD. I will say capital C. So you can see in how many locations that is different. So that will be, I will clear this. GCC str4 minus O a dot out dot slash a dot out. Okay, so you can see when you compare the first string, if I make this both equal, then the result will be 0. So if I make it as CD here, the result will be 0. Otherwise, that will show in how many bytes it is different. Okay, now it is 0. Here you can see that's a 1. The difference is a 1. So if I make this you can see that the difference will be more. Okay. Oh, this is I did a wrong comparison. Yeah, in how many bytes they are differing. Okay, so this is how the strcmp works. Okay, so we have seen strlen, then the strcat, then strcpy and strcmp comparing strings. Then there are some IO operation for character that is like getchar, putchar, etc. This is an alternative for your printf and scanf. The first IO operation you have seen are with printf and scanf from what do you call stdio.h. I have some alternate functions like the getchar, putchar, etc. So usually with this getchar gets a single character from the keyboard, and putchar sends a single character to the screen. Okay, so this is a useful method to talk to external peripherals. I told you primarily C is used for talking with the hardware. So you can see this code here. You can see that hash include stdio.h, then there is a void main, then a character value x is initiated or declared that way, then x equal to getchar. That means the value I input from the keyboard will be stored in the memory location whose name is x. Then I can check it with check with a printf function, or I can use a putchar. Okay, so we will run this code here. This is my code. Here you can see that it is hash include stdio.h, then void main. Within brace I have x is declared as a character variable, and x equal to getchar means whatever is input from the keyboard that will be stored in x. I can check with a printf, or I can use putchar. Putchar will put it on the screen. We will run this. I will clear this. Minus O a dot out dot slash a dot out. Now it is waiting for this character. So if I say D here, now you can see that the value read is D. Now it is here D is printed. Okay, this is the printf function returning the value that is read, that is D, and this is D put by the putchar function. Okay, putchar function. So I can run this again. You can say 1. So the value read is 1. Here also the putchar puts a 1 here, or else I can say capital Z. That will. So this is by reading or putting characters one by one, of course, for talking with external hardware. Now coming to the end, your learning outcomes are you learn to declare and use an array. Then you learn to declare multi-dimensional arrays. Then you realize the strings as character arrays. Then you learn the standard library functions, string functions like strlen, strcpy, strcat, etc. from string.h, that is located in /user/include. And that is the end of this presentation. I thank you all.